Welcome everyone to this week's collective learning meeting and monthly System Dynamics Society's economics SIG meeting. Please remember to mute your microphones unless you want to ask a question. Feel free to use the chat box. If you type a question there, Christine Tang, can ask the question for you, and Tyrone wants us to hold our questions to the end. And our presenter today is Tyrone Keynes. Tyrone is a production manager at a large plant in Canada and learned system dynamics to streamline production and operation productivity. Please take us away, Tyrone.
All right. Hey guys, I'm Tyrone Keynes. I'm glad you joined me today. Just going to start sharing my screen. Yes, I'm a production manager at a large plant. As Christine was saying, 2 years ago, about 2 or 3 years ago, I got into system dynamics, trying to streamline some of the processes at that plant. I've always had an interest in economics. I got hooked to system dynamics a month into it. I've always been a systems thinker naturally. So I started modeling everything. It started off with the pandemic. I've always had a big interest in economics. So I wanted to try to find the causal links between lockdown measures and how it affects employment, inflation, spending, etc. And that's kind of led me to this model. This is a work in progress. I am going to be presenting at the conference this summer virtually, so I will definitely like some feedback at the end. So I use the software program Minsky. It's a little bit unique. It utilizes godly tables for stock flow consistency. It looks rather different than Vinsim or Stella or Insight. I'll take you for a tour on that in a little bit. It has quite an extensive compartmental module to it. I started the model with the pandemic variables first, and I've developed that quite a bit. So there's no need for feedback on that part. I built a lot of feedback effects on people's behaviors, how they encounter the pandemic and how they react. I also built in behaviors where there was resistance to non-pharmaceutical interventions. And that provides a lot of feedback effects. I will say at this point, the economic part is far from incomplete. So when I present it, there will probably be things you notice that are missing that I am aware of. I just haven't figured out how to model mathematically yet and integrate it all. So feedback is much appreciated. What kind of model is this? The pandemic part is a mechanical compartmental model. It does well with existing data that's collected over time. So at the beginning of the pandemic, like many compartmental models, they weren't that accurate until more data was collected. I've kind of back tested it a lot with the most recent data, and it operates quite fine. I modeled specifically here in British Columbia, Canada, with all its data. The economic portion, I wanted it to be stock flow consistent. I'm not an MMTer, but I believe, you know, money goes from one account and goes to another. It's mutually exclusive. And I think that's a good foundation to model an economic system. Size and composition of the model. At this point, there's 47 system states or stocks, 69 flows, 54 parameters. In Minsky, you can adjust your parameters at the beginning and then actually run the simulation and adjust parameters as you go. So you can run the model and adjust, let's say, your interest rate or different lockdown measures as the simulation is running. It has 154 constants, 56 auxiliary variables, bringing it to 365 total variables. I really rely on Minsky for its godly tables. Again, it's for stock flow consistency. I'll kind of demonstrate what they look like here in a second. But really, you know, all financial flows start somewhere and they end somewhere. And that makes it feasible to have exclusive transfers from one location to another. I find that very important. I also utilize these godly tables in the pandemic portion of the model. You either have COVID or you don't have COVID. You're either in the hospital or you're not in the hospital. Again, it's mutually exclusive categories. So the godly table came in handy for that process. So this is one of the godly tables in Minsky that I use. This one is for the pandemic portion of the model. Along the top row are all your stocks or compartments. And then down vertically are your flows between the compartments. And it's really easy when you are dealing, you know, in this situation, there's 26 system states and 48 flows. For me, I found it very easy to make sure that my flows are going in the right direction, and everything was organized versus having a bunch of pipes and boxes on a canvas. You look, it's quite simple. You know, you get exposed. Well, you're susceptible, you know, that's a minus E. You go into capital E, which is exposed, and that's an E. I'll show the monetary godly tables when I present the model here in a moment. That is a big part of Minsky and how it works. Most of my feedbacks right now are within the pandemic portion of the model. And like I said, the pandemic portion is driving the economic variables to a large degree right now. And on the pandemic portion, I focused on social perception, social stress, individual behavior, the NPI policy, which is set by the user. Interestingly enough, with Minsky, you are running the simulation in real time. So in a roundabout way, you become a variable yourself, which is kind of interesting versus other programs. There's a few other variables that influence all the feedback effects pertaining to the pandemic portion of the model. I'll just kind of go through these fast because I want to focus more on the economic parts, but that is kind of the structure of my feedback effects. I did put a little box in NPI policy, which is exogenous, but because you are running it on the fly, it creates some interesting dynamics yourself, being a variable in the system, and I'll demonstrate that in a bit. Areas of improvement or expansion. Well, in the economic side, there's a lot. One of the things I want to do is add a nonlinear wage function, maybe a Phillips curve or something along those lines. I'd also like to add a nonlinear investment function. Right now, my investment is fixed with a lot of time constants, and I definitely want some I definitely want to function for a high profit, over investment, debt, kind of thing in it. So I need to work on that. Obviously, more feedback dynamics. This is system dynamics. That's important to me. And a better endogenous and inflation and interest rate functions. I do have endogenous inflation and interest rate functions in this model. But there needs to be a lot of work on it right now. If anybody's interested, Minsky is free at SourceForge. It's still under development. It was invented by Professor Steve Keen and coded by Dr. Russell Standish. I also do all the promotion online via social media. I have a YouTube show to demonstrate how you can use Minsky for system dynamics. And I will just switch over to the model. So this is Minsky. This is me zoomed out, showing all the different parts of the model. Just go through it quickly here. The pandemic part is basically a state reset. You take in the best data you have available to you and set your parameters at the start. You can adjust these parameters as the simulation's running. Because I don't have different variants in this model. If you want it to simulate, going from Delta to Omicron, you could do this manually here. This was the stock flow chart I showed you. You'll notice here that it has assets and liabilities and equities because these were designed for financial flows. That's why they're there, but they can be used for any mutually exclusive units. This part's a little bit different than, let's say, VinSim. You do all your mathematics directly on the canvas. So for defining how people become exposed in my pandemic model, it's susceptible times infection divided by population, and alpha gives you the exposed flow. There are no actual wires in Minsky connecting the flow to the stock because that's done in the Godley tables. I can integrate directly on the canvas. I've just chosen in this model to do all of my system states in Godley tables. But I did kind of, put some lines to show the flow between the stocks and all the different compartments, just for a visual perspective. I'll go to some of my auxiliary variables and the feedback for the pandemic portion of the model. If anybody has been involved in engineering, Minsky uses what's called heaviside switches. So these are all my parameters you can set as a user yourself during the simulation for lockdowns, and that increases the doubling time rate, or the time constant, which means there's less exposure. That's an exogenous kind of driver in the model. I have an automatic season change, which changes the exposure rate. I know a lot of people don't like, a stochastic type system in system dynamics, but when I first started creating this model, I envisioned showing a policymaker, and I wanted them to have kind of a realistic view of how they could handle a pandemic. And if you looked at the data, it's very choppy, mainly because they wouldn't count on weekends, or they wouldn't count on a Wednesday, or, for whatever reason, somebody didn't get tested. So I've kept that in there. I could turn that on and off if I wanted. It makes the graphs more realistic, but it doesn't serve much of a purpose. I also have like a social stress function here. Basically, over time, people become tired of lockdown measures. They have the expectation that getting vaccinated will solve the issue, and that actually feedbacks into the issue of social stress, and that all feeds into my alpha rate. I also used an exponential function for positive social behavior, and that is without any lockdown policies by government agencies, people themselves will wash their hands more, wear a mask voluntarily over time or during each wave of the virus. And most of the rest of this area is me just defining variables for the graphs. I have a testing capacity kind of function that could use more work. So basically, like I said, I'm not an MMTer, but I believe in stock flow consistency. Right now, this is a very, very aggregated view of a national economy. I'd like to extend this where I actually use Canada's national accounts. But right now, just getting it structurally sound, this suits the purpose. See if I can zoom out here a bit. So, a flow issued loans to firms, that's obvious. This is the banking's perspective right now. So it's an asset to the banking sector. The firm bank accounts, so that would increase their accounts. Paying the loans would decrease their account, and it would decrease the asset of the banks. Paying interest, which is the bank's income, would go into the bank equity. It's along those lines. What else? We could have taxes being paid, actually decreases the bank's reserves, because those reserves are basically an asset swap at the central bank out of the treasury account. And so this is how I usually start with godly tables to make sure my logic's correct. So you'll see taxes being paid. It's a decrease on the bank's reserve and an increase on the government account at the central bank. And all of these are all interlocking balance sheets. So for the bank's perspective, the firm account's a liability. Obviously, from the firm's perspective, it's an asset. And this is my beginning to define all the economic variables. And this is where I still have a lot of work. It's a mess, I understand. Right now, I am ashamed to say maybe that I'm just using a Mark style turnover rate for my capital output simulation part of this model. Ideally, I'd actually want to have a stock of capital that produces output, but right now this is serving the purpose. And that gives you gross domestic product. I have a fixed productivity rate that gives me employment. Obviously, I could have a growth aspect added onto that. Right now, my wages are fixed to GDP. I want to add a wage function, and I will in the future. Same with dividends being paid to capitalists. What I have more fully developed is my price function. So I do have prices. I have not attached those prices to all the different variables, but I do have a system of inflation and deflation in the model, and that is driving the market interest rates. A lot more work can be done on it, and I will do that over the coming months. The rest is all defined mostly by time constants and my alpha rate from the pandemic model. As alpha goes up, obviously there's more lockdowns in the system. In this case, right now, this is subjective on my part. As lockdowns go up, more people need loans because they have less income. I know that situation can be reversed in some situations, and I'll try to, address that a little bit more as I build this out in the future. And it's vice versa with loan repayments. People pay off their loans as they have more income, which is pretty much a logical statement. So if there's less lockdowns, there's more income because more people are working to pay off their loans. The rest is really basic tax rates, which you can adjust to see the dynamics of that. A simple function between banks buying government bonds and the central bank buying government bonds. Right now, I have a 10% reserve ratio to kind of decide if the banking sector is buying or if the central bank's buying. A lot more work needs to go into that. Just some other variables for the graphs. I'll just start running this model just so you can see. I'll start from the pandemic dashboard. I have two dashboards for this model. I think by the time of the conference and my limited time to present, I will just have one dashboard for the economic graphs and the pandemic graphs. So right now it's started, it's at 13 days into the pandemic. Not much is happening yet. We have the economic dashboard. Right now, like this would be the highest frequency data you could ever get, daily data on GDP. That would be an economist's dream. Right now, interest rates are going down. It's a little bit of a delayed reaction to inflation slowing down or speeding up. Right now, I just have a price index, not inflation. I probably would like to have an inflation graph. I can speed this up, but without any lockdown measures, because that portion of the model has a lot of endogenous effects. It has its own waves as people protect themselves. And now we're seeing the first wave. People are staying home. And there is right now a tug of war between people staying home and needing to go to work. Unemployment's going up. I can increase government spending to try to counteract that. That's pretty inflationary, although it's exaggerated in this model. I could lower the discount rate, which has an effect on the market interest rates. The discount rate, I mean, as the rate that you can get a loan from a bank can get a loan from the central bank. I can adjust tax rates. I kind of just ran that fast, and in the background, you know, I obviously have the pandemic portion of the model going. I haven't adjusted or prevented any spread. And right now it's at a very, very high, looks like steady state of infections. So I can restart the system and just kind of show that having the NPIs is quite a burden on economic variables. Just start launching some of them here. And I won't do this in any specific order. So we can go really heavy on policies here and have a very shallow wave. Unfortunately, that has a huge economic impact, and this was a real world struggle we had for the last 2 years, and finding a balance by having all of these measures in place, and what kind of government spending could help balance it out. What sort of interest rate policy should we have? And that's kind of, you know, where I want to take this model, is have a system where we could find that balance. And it might be a little bit late now, you know, 2.5 years into the pandemic, but with global warming and deforestation, I imagine our next pandemic's not going to be 80 years from now. It will probably be a lot sooner. So hopefully there's more models like this. So yeah, that pretty much concludes what I have so far. And like I said, it's very basic. I know it needs a lot of work. There's a lot of logical inconsistencies. So I will accept any feedback. You can unmute, you can ask questions.
Yes, Tyrone. First of all, your work is in a different language than most people will use at the conference. So they might ask you a lot of questions while you're presenting on the technical aspects of the structure, because I don't expect many people will understand Minsky. I was in a presentation by Keynes in which he showed us around Minsky, and he did make available a copy, and I tried to play with it. And it's very different in terms of most people at the conference will view the structure. Secondly, it's a very large model. You have like 365 variables and constants. I also noticed you had parameters and constants, and in system dynamics, parameters and constants are the same thing. And some people will probably ask you what's the difference.
Yeah, so in Minsky,
I caught these things, and I have to admit that while your input is in terms of godly tables, that's how you input data into the system, or
the initial conditions, yes. And just defining which flows go to which stocks.
I see. And whereas we actually connect the flows and stocks in our flow diagrams. So there might be a lot of questions about how those godly tables translate into stock and flow structure. So I think before you get into the logic of the model, there might be a lot of questions about the logic of the software. That's how I feel. Maybe others have other inputs to this. also, I think people might ask how those patterns develop. What's the logic? What's the explanation of those patterns as you show the patterns develop? People
Yeah, for
would
sure,
want-
for sure. I want to develop some causal loop diagrams for the economic part. I just haven't yet because I want to finalize what those feedback effects are in the economic part, and I'm still kind of exploring that. So that'll be a big part, I think, to people understanding the logic of the model. I think you also raise a good point because in the community, the system dynamic community, godly tables are unknown. So it's might be a hard, you know, in a quick presentation, it might be very hard to conceptualize what I'm showing. So maybe I might have a demonstration of a traditional stock flow diagram and then compare it with a small godly table. Right now, if I were to design a stock flow diagram for, you know, 60 plus system states, it's a mess. It's a spaghetti diagram. And that's why I like Minsky. But I do.
Unless you use a hierarchy as is available in Stella, you can pack you can partition your model and pack those partitions into the modules. And the modules can be arranged in a hierarchical way. Kareem actually reprogrammed Forrester's urban dynamics model, which had 20 stocks. And since Stella generates the causal map between the causal map at the modules layer, so it could generate the causal loops underlying the logic, and that could help explanation. I don't know. I honestly don't know how Minsky works. You mentioned you'll develop the causal diagrams. The question that came to my mind was that would those diagrams be generated by Minsky, or would you draw them separately?
It's separate right now. Right now, the developer is working to have that integrated. It's, you know, this software package has only $500,000 of development time in it at this point. So despite its unique features, it's also missing a lot of features that are really necessary for the wider use of it in the system dynamic community. So at this point, yeah, I have to do it outside of the program.
Yeah, my suggestion would be to show a simple causal structure of the pandemic model, and then a simple causal structure of your economic model and how they are connected. Give a very brief explanation of Minsky using a very simple model, as you mentioned that you plan to do, and then go to the results. Maybe that thread of presentation will fly. I don't know. Perhaps.
Okay.
Hi, Tyrone, this Ken Cooper. I think Khaled's exactly right. I think one of the things that's useful for any system dynamicist is to not necessarily wait until the model is final and coded, and then use software to produce an as-built drawing, but to use the even hand sketches for whatever method you might choose to build, to draw a exactly the kind of overview or summary that Khaled was just talking about for the sectors and their interconnection. That would help. I think it not only helps to explain to others, but at least in my experience, it's always helped me figure out what am I missing here, or what needs to be different about this, simply by reviewing the diagram at the, just as a starting point. I thought.
Yeah, I completely agree. In some situations, I have done that. In this model, I won't lie, I've become overwhelmed at points, and it's become a freestyle endeavor of just plugging things away on the canvas. So I do agree. I probably would be better suited as I kind of build this out and get the logic right to do those diagrams ahead of time.
Rafat?
This is Rafat. Thank you, Tyrone, for the presentation. I think my feel is that there are two threads or two narratives going on. One about the model and its novelty, and what does it contribute, and then how it is modeled, which is the software part. And I think these can be two mutually exclusive threads. If you're focusing on showing the impact of the pandemic and the economic policy, then I think that going through the software and how it looks like and its advantages is disturbing the picture. So it really depends on your objective. If you're showing the power of the software and using the vehicle of the model and using the model as a vehicle, that's a separate, and it has its own right, I guess, and its novelty, and also the model itself and what gap it tries to close or to contribute to. So it really depends on your objective. I don't know how the paper was written. What did you write in the conference paper, and what conclusion?
It's completely just in the Model Expo. I haven't done a paper.
Okay, so it's a Model Expo. Okay.
Yeah, it's definitely, and you're right. I have not decided, even though I have a closing deadline on what the title of this model is, if this is a vehicle to promote Minsky, because I believe in it and I'm buying into it as a system dynamic program, even though it still needs more development, or is it about all of my work on building out a pretty large pandemic model and how that affects economic variables? I haven't made that decision, and you kind of vocalized it perfectly there, that I'm kind of in the middle right now.
And honestly, I think your enthusiasm shows the latter part, which is the software and its use. And I think the field would benefit from diverse software and approaches. So if you are finding that position you feel more comfortable with, go with with your guts, I would say. Thank you.
Thank you.
So in the chat, D. Arthur.
Yeah, hi, Tyrone. Yeah, thanks for that. It's interesting to see, given that I know something of Minsky, although I haven't spent a lot of time with it. But I've got several questions, really. One would be, as is hinted, what would you say is the purpose of this model? Because I'm not sure. Is it to try and showcase what Minsky can do? Is it to show the effects of NPI policies? Is it to examine the behavioural effects that are going on in the pandemic? So I'm currently working at the UK Health Security Agency and spent some time reviewing models of the pandemic from an economic angle. And there are a lot of questions that arose, and I was trying to promote more of a systems and a feedback type perspective compared to all the other models that I reviewed. One of the issues was about the strength of the NPIs and the relationship between the stringency on the economy through the mechanisms of the NPIs. And existing models are attempted to estimate the effects by using linear regression. Of course, I was critical of that, but one of the issues that could be asked about your model is, well, if your purpose is to try and estimate the scale of impacts, where do you get your parameters from for the effect on the economy of the NPIs? And do you recognize that it actually changes over time because of behavioral response and feedback effects? And your model might be trying to examine that. So come back, I'm sorry, I've said quite a lot of things there, but coming back to the basic question is, what's the purpose for your model? Another one I might ask, if you can remember this, is given that your model is stock flow consistent, what do you think from a system dynamics angle, what is the gain here of being stock flow consistent for this application? Because it seems to add quite a lot of extra complexity to include all the financial flows. Or what's the benefit of doing that? So probably the biggest one is what is the purpose of your model?
Well, to answer yes, yes, and yes. I know I need to more clearly define a focus. As it stands, I could strip out all the economic variables and just run it as a compartmental model and have its well-developed feedback effects, and it stands alone. I have a passion, I guess you could say, for economics, so I want it to develop. I wanted the main purpose of this model to show the NPI's effects on economic variables. So if it was, as a situation kind of driven issue, I would want it to be based on how the NPIs affect the economy. For stock flow consistency, if you wanted to develop functions mathematically, and it's based on where your money is, what the wage share is, which I haven't really developed yet, or different shares, you need to know where the money is. You can't have it disappearing into clouds and then create variables out of unknown clouds, and they're not defined. So it does add a lot of complexity now. But if I wanted to further, let's just develop the economic part, or just exclude the pandemic part and just have a full economic model. You've got to know where your money is. That's the real world. Money doesn't just disappear. It goes somewhere, unless it's paid off and it's destroyed as credit at a banking institution. So it's fundamentally important to track your stocks. Now, you can have your system boundaries, obviously, where you're not tracking it. But in this case, I'm trying to look at the entire aggregate economy. So where is the money going from one spot to another? And then how can I use that information to create functions? For instance, building out a price function, or an interest rate function, or an investment function. I need to know where the money is, and I need to know that it's logical. So that's the importance, I think, of stock flow consistency in economics. To leave that out is foolish in a lot of ways. We measure our economy on monetary values. We use adjustments to create real values, but at the end of the day, we measure our economic performance out of monetary values. So we need to know where the money is. And that's why I think stock flow consistency is important.
I also want to suggest to take a look at this book that Kaoru Yamaguchi has written. He's a traditionally trained economist, but the models in the book are in Stella, and he has actually emphasized the financial sector. What he calls through designing the accounting system. So he tracks the money. Basically, the stocks of money are connected into a one big conservative system, and then how those stocks factor into various decisions. At a simpler level, our colleague David Wheat has developed models which connect financial sectors and the production sectors of the economy. They both have used Stella software, but they might be worth looking at. One thing that I sort of fear is that at the conference that you're presenting, the software might just hit them as something totally different they have not seen. So if I think Rafat's point was well taken, that if you want to explain the software, maybe you want to make two presentations, one in this software segment and the other on your model, which should highlight its feedback structure and discuss the results and say that, yeah, you have made the presentation about the software in another meeting.
I don't know if you want to respond to that, but there are other
Um,
questions in the chat.
Yeah, again, that's a very important point, is how am I driving this presentation? I think my gut is I am a system dynamics fan, and I'm a fan of Minsky. And I want to show that off because I think that's new in itself, and that would contribute to the community as a whole. That's what anybody wants to do, is contribute to their community. But at the same time, I want a unique model, you know, so it's a tough trade-off, right? Like,
My personal opinion is do what's best for you personally. And do you actually work for Steve Keen? I don't know if this is an appropriate question. Do you
we
actually
are,
work?
yeah. No, we are collaborating on a lot of projects right now. Me and another guy are putting together some online courses based on his work. So he'll present the lecture in a bobblehead format, and we'll use the Minsky software to kind of flush out his ideas on the Minsky moments and godly tables. And then right now I'm volunteering just to get Minsky out there in social media. We're kind of guessing maybe another year and a half before it's really finished. There is another component called Ravel to it, which takes in data. And instead of using a spreadsheet, you can take comma separated variables, files, and take all that data, build graphs, and actually have that inside of your model too. So you can regression analysis or other little neat features. So it's all about a year and a half to 2 years out. So right now we're just starting to finally, like, this has been developed now for 8 years. So we're just starting now to put it out there and get feedback on what needs to be in place before it goes commercial. So that's how we work together.
I was just curious, and I'm wondering if a model expo is just the first step you want to make if you want to demonstrate Minsky, or you should have a workshop at the conference, which makes a lot more sense to me personally. A workshop.
Yeah, I'm not too sure. Like, honestly, like when I submitted the model, it was a stripped down version months ago. And I didn't even expect a response, to be honest. So I just got the email a few days ago. So I'm taking it and going with it, right? It gets Minsky out there, gets me out in the community. I don't know where my future goes with this. If I end up consulting, I do have a little side project. I'm working with a nonprofit society modeling incarcerated individuals and the cost on the system. So, you know, it's also about getting me out there into the community and taken seriously. So yeah.
I think you have an opportunity because the theme of the conference this year is about diversity. And I think adding this line and this would be of help. But if you kind of find a different, and maybe it's too late in the conference program, but if you can schedule a session or a round table or something where you can have more time and get feedback that is really focused on either your economic work or the software, it's a great platform.
Yeah, I'll try to reach out and see if there's any options. Like you said, it might be a little bit too late for this year. But really, I think what I'm getting back out of this meeting is I have to define what this presentation truly is about. Is it a pandemic, economic, or is it, you know, a promotion of Minsky? And I think I really need to decide. Clear.
As Dan pointed out, it's the model is very interesting, and also the other threat. So it's a choice, but it never hurts to ask. By the way, even if people think it's too late, just ask.
Yeah, I'll look into the scheduling part of it and see what happens.
So there were some questions in the chat. Ken asked, have you tested the actual series of government interventions to simulate what happened in the economy? If so, do you see more effective policies in your experiments?
Right now, it's very just loose correlation, and I'm working on the real causal effects. So right now I have pseudo initial conditions right now for the economic variables. Everything has been tested on the pandemic side, but the economic side, yeah, still a lot of work. I've looked at graphs, I've taken in spreadsheets and tried to adjust the parameters of my model to start going in the right direction. But as a predictive tool, I wouldn't go there yet.
It seems that it's got a lot of parameters in there. And it's a lot of effects to estimate.
Yeah, in a lot of models I have found, and people go about this different ways, but I overbuild and then I cut. So even just a very basic example, an interface to see all these graphs, I don't want to. I may not need 26 system states for where people are in the system with COVID. That just truly might not be necessary, and it might not be giving me any more detail to my feedback loops. I might not need a central bank in my model to get the data that I want, unemployment, inflation rates. But I'm very much build it out and see what happens, and then see, okay, this isn't working, I don't need it. So I imagine by whatever I present at the conference, there'll be less. I would hope more feedback effects, more causal links, but less volume in the total size of the model.
I mean, I'm intrigued by this approach, Tyrone, because building then cutting, it makes it hard to troubleshoot your work or test it and build confidence in it if you overbuild and then cut. So I think that's part of, if you want to get a finished work that incrementally improves, that could, I just don't see how you can go back, because it's very hard to be attached to something and then remove it or test it and defend it. And if you want to write something about it so that the public would benefit, that's a very hard, but I might be wrong. But what's your perspective on this?
So in like everybody has a unique, I think has a unique building process. So for me, there was probably 100 different components of this model that I built by itself just to see what the dynamics were. And then I put it together with other components. In my decision-making process along the way, I didn't scrutinize too much. I wanted to build something up. And just in my process, once I see the dynamics work in these individual components of a model and there's logic behind it, add it. And then when I have a fuller picture, then I start realizing, okay, this isn't giving me any data, useful data. I don't need it anymore. So that's kind of like my process. It might be wrong. I'm not educated with a master's degree in system dynamics, so I may be going about it the wrong way. I'm not too sure. I'm self-taught with system dynamics. But that has been that's how my process has evolved over the last 3 years in building models. I don't have any other examples of a model this big because I don't have another model this big. But that's been the process, is I've built small chunks, and those chunks I put together after I found that there was logic behind them and the system worked. And now I have this large model, and I am recognizing there are some parts of it that don't serve a purpose, that I thought maybe I could, get data out of, create functions from in the past, but I'm realizing now, there may not be any use for it.
If there are no more questions, I just want to say thank you, Tyrone, for presenting today, and others for attending, even though it's summer break for some people already.
Yes, thank you.